Welcome all to yet another video in the series of Hadoop for beginners. Today we'll be looking at, so here as you can see it says Apache Hadoop ecosystem. It has got a lot of blocks, so a few vertical of them, few horizontal blocks. The lower blocks are HDFS, then the one sitting on top of it is MapReduce. Then we have the Flume, the Scoop, then we have HBase at the right corner. We have Ambari controlling everything. Then we have Uzi, Pig, Mahout, RConnect, Hive, and Zookeeper, of course. So this particular picture you must have seen everywhere when you go for learning about Hadoop ecosystem. But then this is pretty confusing as to who is doing what is the role that SDFS play, what is the role that Zookeeper play, why is Ambari sitting on the top, what is the significance of this Scoop and Flume on the left. So what I did, I have created a simplified block diagram that will give you an overall idea as to what all these singular blocks are doing here. So in the next picture, you can see the entire ecosystem has been divided into 3-4 blocks. The first one, it says as for the data ingestion of it. Now, what is a data ingestion? Now, the data ingestion is, as you know, that HDF or the Hadoop ecosystem does not produce data by itself. It has to get that big data that we're talking about, the lingo that we're talking about, from outside. So this is what the data ingestion does. The Flume and Scoop, and mind you, these are just examples in an application, Flume and Scoop. There are a lot other which you can use for ingesting the data. Then that data that has come down to the that is coming to the Hadoop ecosystem goes for storage. Now, when you've got the data, you have to store the data somewhere. So that is where the SDFS or the and the this HBase comes into picture. And then we have stored the data, then we need to process the data. Why have we got the data inside our Hadoop ecosystem? Because we want to process something on it, we want to get some analytics over it. So for that we have this Hive, Pig, MapReduce, and various others. Now when all this data has been ingested, has been stored, has been processed, then this data has to be used for something. Then we have some high level data analytics like Mahout or RConnect, which the data scientists use. And then this particular everything has to be closely correlated and coordinated and managed. So for those we have this Ambari, Zookeeper, and Uzi. All this were the significance that every block and every component has, we'll be seeing in the later part of this lecture. With the first definition, as in what is an ecosystem, like it's a common lingo used everywhere. It says Hadoop ecosystem. Everywhere you'll see there's always a mention of ecosystem. So what exactly is an ecosystem? So an ecosystem are entities related or unrelated that come together for fulfilling a common goal. Like let's forget about Hadoop. Let's see in our environment, the earth that we live in, there's an ecosystem. There are every living organism, right from bacteria to a dinosaur. Everybody has its own significance. So in the same way, in the Hadoop ecosystem, every particular application has its own significance. Okay, so a Hadoop ecosystem is a framework where different components come together to solve big data problems. Okay, so when it initially started, the components like SDFS and MapReduce were mostly in Hadoop 1 they were used, and which were used to solve the issues of storage and processing. But to make the ecosystem more scalable, intelligent, user-friendly, robust, and most importantly, the manageable, other several components were added that we have seen in the first slide. Now, we'll begin with our first block of the ecosystem, that is the data ingestion. Now, this lingo data ingestion is used for getting the data from the outside, the big data from the outside world into the Hadoop ecosystem. So there has to be a process for it, there has to be applications for it. So here we have Scoop and Flume that are widely used for data ingestion application. Now, having said that, let me remind you, these are just the examples. There are many other applications that can be there, except for Flume, Scoop. There are other examples that can be there for data ingestion. Okay, and why only data ingestion? For all other data storage, data processing, there are many other applications. So first we'll see what does a Scoop do. Now, Scoop is an abbreviation and it stands for SQL plus Hadoop, right? So it helps in getting the data in and out of RDBMS system like Oracle, MySQL, etc. to Hadoop. It generally deals with the ingestion of structured data. Now, what happens if you have a structured data format? Let's say the RDBMS data that is stored in a tabular format. So, if you want to ingest that into the SDFS into the Hadoop ecosystem, that scoop is particularly used. Then we have Flume. Now, Flume is a distributed, reliable, and available service for efficiently collecting, aggregating, and moving large amount of log data. Let's emphasize on the log data part of it into the Hadoop distributed system. A Flume, the Flume helps in the ingestion of semi-structured and unstructured data. Now, what does that mean? That means that the problem here with the RDBMS system that we use, let's say Oracle and stuff, the data is structured. The problem is that data has to be structured. It has to be a relational data which is stored in tables in the row format and stuff. But there are a lot of data that are unstructured. Let's say log data. Now, to understand this further, I'll just like try to bring your attention to. Have you ever wondered that when you go to a particular website, let's say an e-commerce site, you serve something you want to buy, and then you get out of there, you don't buy them, but you just serve, you just want to know what is the cost of this particular mobile, and you just start browsing some other is a web application. And when you start browsing some other website, you'll find that the same things that you were browsing on the e-commerce sites let's get started reflecting everywhere. The advertisement is everywhere else. So how does that happen? So there's a thing called click log. Now, what does a click log do? The moment you click on any of those products on the e-commerce site, it keeps a log of whatever you are clicking. So whatever you like, and then wherever you browse, wherever other sites, whenever you browse, they keep on showing you the same products advertisement. Now the advertiser use this with the idea that the more you look at those products, the more the product is in front of your eyes, the more is the likability of you buying it. So how does this happen? So that click log gets stored into the HDFS system through Flume as it is, as a log. And whenever there is a need for retrieving it, it gets retrieved back as a log itself. Okay. So that is an unstructured data. It's a log. It's a text file. So that is what Flume is best at doing. Moving forward, now that we have ingested the data, we'll look into where the data gets stored. Now this SDFS, that is the Hadoop Distributed File System, is one of the most important and one of the most basic components of Hadoop. This and MapReduce, well, like the pioneers in the Hadoop ecosystem. Now what happens? Why is it called the Hadoop Distributed File System? What happens? When a data is ingested inside the HDFS environment, or let's say Hadoop, and it is stored in HDFS, the data is broken into parts and it's stored in a distributed fashion, where it's stored in a form of files. If a data, let's say a file is brought in, it is stored into different small parts, and all those parts are itself a file, and that is stored in different nodes. We'll look more of this when we'll be doing a separate class on HDFS, where we'll see what are data nodes, what are name nodes and stuff. So for now, just focus on this HDFS is a distributed storage kind of thing, where when a data is brought in, the data gets stored into the nodes in a distributed fashion. So what is the advantage of storing data in a distributed manner over different nodes? So what happens when you store data, when you break data into small parts and you store in distributed manner, it gives a huge boost to the speedy data processing. What happens if you have data, let's say you have a data of 10 MB and you store it into two files of 5 MB. So those two files of 5 MB can be processed simultaneously and parallelly from different nodes. So this gives an advantage of data being of the time being half of what would have happened if the data would have kept as one, like the entire 10 MB. Okay. Data in the data storage, we have HBase. Now, HBase is a NoSQL database. Now, what is a NoSQL? Now, NoSQL means not only SQL. Now, what is a not only SQL thing? So NoSQL is an approach to database design that can accommodate a wide variety of data models, including key value, documents, columnar, and graph formats. So what does all these key value, document, columnar, and graph formats mean? This means that people who know RDBMS would understand that in RDBMS, there has to have a relational thing with the entire data. The data have to be in relational tables, and their tables have to be all the tables have to have some relations amongst themselves. But that does not happen in an NoSQL database. Now, in a NoSQL database, you can store data in a columnar format or in a graphical format, and data relates to one another via the mapping of graphs. Okay, so and this NoSQL database is very useful when you're working with a big set of data like they're in the big data environment. Now that we have stored the data, we'll see what data processing is. Now you can see we have different kinds of processing. We have pig, we have hive, and we have MapReduce. So first of all, we'll see another of the very basic component of Hadoop environment along with HDFS, that is the MapReduce. Now, like the HDFS, MapReduce 2 is an integral part of Hadoop environment. MapReduce is a distributed, let's emphasize on distributed, data processing framework. Now, why is it important to emphasize on distributed? Because now, like in HDFS, it's a distributed kind of storage. The same way MapReduce is a distributed kind of data processing framework. Its basic concept behind any data processing that takes place in Hadoop environment, and hence the framework. Now, what is a framework? The framework is the basic idea on which everything else works. Now, MapReduce, now you must have seen MapReduce written a lot of times on a lot of videos, on a lot of theory sites. There it is written always without the hyphen, but in my lectures I have always maintained that map and reduce are two different codes and two different Java codes that are there, and they have two different functionality. So always maintain that mapper and reducer are two different things. That is why we have put a small hyphen there. We'll see more of this when we do a separate lecture on the MapReduce. Now MapReduce, this is very important, codes are written in Java language. Okay, so what happened that as MapReduce is written in Java language, including me, are not that proficient on Java. So what happened in the later on when Facebook was getting very popular, and they actually went for this SDFS or Hadoop ecosystem, and their developers were finding it difficult to code everything in Java. So what they did, went on at developing a high level API which could write the codes in SQL on the top, and indirectly those codes will produce a MapReduce code at the lower level. Getting me? So what happens there is people are pretty well versed with SQL. So when they used to write codes in SQL, and on the lower level, those codes were getting converted into SQLs. Now Hive uses the syntax is almost the same as SQL, but there are except for some differences here and there, and that is called, the language is called HQL, that is hibernated query language. Again, there is another data processing tool that we have, that is Pig. Now, Pig is a scripting language. Now, just like Hive, it's a high-level API which the users use to write codes in. There's simple language. If you see the Pig code, you'll find there that it is written in pretty simple languages where there are not much restrictions on the type of syntaxes that you use, and it's very easy to write. And then again, it's a high-level API on which, on the lower level, the MapReduce codes are getting generated automatically. The advantage of Pig over Hive is Pig is able to process unstructured and semi-structured data that is not possible to be processed by Hive. Okay, so that we have ingested the data, we have stored the data, we have processed the data. Now, using that processed data is being done by such certain high-level APIs like Mahout or RConnects. That's mostly used by the data scientists for machine learning and data statistical calculations, and the output of which is being used by the organizations for getting their business analytics and stuff. Having seen all of this, now we should be aware of the fact that we have included a lot of components, different components inside a particular Hadoop ecosystem. Now, if we have so many components in an ecosystem, then there has to be something that can manage the entire ecosystem. There has to be a coordinator. So here we have certain applications like the Ambari, the Zookeeper, or the Oozy, who help the entire ecosystem into running smoothly. Okay, so they have to have administration and coordination control over the entire ecosystem. Now, in Ambari, what it does is it helps your life easy. It makes your life easy while creating a cluster. Now in cluster we'll see what a cluster is when we do a lecture on the data nodes and the name nodes and how a date node is added and how a node is decommissioned. So it makes life easier while creating a node, creating a cluster, then provisioning it, managing it, and monitoring its performance. So any changes that is required in a cluster can be easily done through Ambari. Now again a zookeeper. Now that you can see, we have pig, we have other, the kind of animals, the names that they have given to the animals. Hadoop itself was the name given to an elephant. So all these, when you have all these there, then we need a zookeeper to keep them in check, to have a coordination between them. So then a zookeeper provides the coordination and synchronization between the Hadoop components. Okay. Now, having talked about the other parts of it, now Oozy. Now, Oozy is a job scheduler. Now, what does a job scheduler do? It lets you schedule your job. If you are not planning to run it in real time, it lets you schedule your job for later hours. Let's say when you are working in production, we generally don't prefer scheduling or running heavy jobs in the time of business hours. So people who might be working on SAP ABAP, they must be knowing that there are few transactions like SM37 that helps you schedule your job after the production hours or after the hours which you feel free, which you feel that is most suitable for that job to be running, or when you want that output of job to be used for on some other job. Now what Uzi does, what happens in this environment of Hadoop. There are a lot of jobs running simultaneously. There are MapReduce jobs, Pig, Hive, and they has to run in coordinated manner because output of some will be as fed as input to the other. So that is where Oozy comes into picture. So that is how a job scheduler works. Now the biggest advantage of Oozy here is, now let's say a job A and B has to be running on the environment. Now the output of job A will have to be treated or is to be treated as an output of as an input of job B. Now what Oozy has a mechanism that it does not let job B to start until and unless the job A's output has completely come to it. That means till the time job A has been completely finished and the system is confident about the entire output, then only the job B will start and it will be fed with the output of job A. So this is how Oozy is important. This is how Oozy manages the system. Thank you very much. Now I'll request you to please like and subscribe our technologies. We are working really hard to make this the entire Hadoop for beginners really easy so that we can understand and the Hadoop taboo can be gone. Thank you so much.